Bitcoin script instructions. Let's understand the Bitcoin script instructions in a little more detail. A script is really a list of instructions which is recorded with each transaction, which describes how the next person who wants to spend the Bitcoins which are being transferred can get access to the same. Bitcoin scripting language is small. It consists of 256 opcodes, out of which 15 are disabled and 75 are reserved. Opcode is defined as an instruction which tells the processor what to do with the given variables of data. Each instruction is given 1 byte. Opcodes have the following: constants, flow control, stack, bitwise logic, arithmetic, crypto, lock time, pseudo words, and reserved words. Evaluating Bitcoin transaction script. Now we will evaluate the Bitcoin transaction script by taking a look at the step-by-step execution of the combined script, which will prove that this is the valid transaction. The execution pointer starts by pushing the value sig to the top of the stack. The execution pointer then continues to move right with each step. The next step is to push the value public key to the top of the stack on top of the previous value. Then the dupe operator duplicates the top item in the stack. The resulting value is pushed to the top of the stack. In the next step, hash 160 operator hashes the top item in the stack. The resulting value is then pushed to the top of the stack. Then the value public key hash from the script is pushed on top of the value public key hash calculated previously from the hash 160. The equal verify operator compares the public key hash encumbering the transactions with a public key hash calculated from the user's public key. If they match, both are removed and execution continues. Lastly, the check_sig operator checks the signature, matches the public key, and pushes true to the top of the stack if it's true. If the scripts return true, the transaction is considered valid. Bitcoin network node, Bitcoin network. Bitcoin network. Bitcoin is an ad hub network with random topology. The protocol runs on the TCP 8333. All the nodes are treated equally in Bitcoin network. New nodes can join the network anytime, and the non-responsive nodes are removed after 3 hours. Bitcoin network node. Nodes in the Bitcoin network may take on different roles depending on the functionality they support. A full Bitcoin node is a collection of 4 functions. The first function is wallet. A wallet is usually a part of the full node, especially in the desktop Bitcoin client. The second function is a miner. Some mining nodes are also a full node, maintaining the full copy of the blockchain. The others are lightweight nodes participating in pool mining and depending on a pool server to maintain a full node. The third function is a full blockchain. Full node maintains complete and up-to-date copy of the blockchain. Full nodes can authoritatively and autonomously verify any transaction without external reference. The last function is network routing node. All nodes include the routing function to participate in the network. Types of Bitcoin nodes. Now let's take a look at the different types of blockchain nodes. First is a reference client. This client contains a wallet, miner, full blockchain database, and network routing node on Bitcoin P2P network. Second is a full blockchain node. This contains a full blockchain database and network routing node on the Bitcoin P2P network. Next, we will talk about a solo miner. Solo miner contains a mining function with a full copy of blockchain and a Bitcoin P2P network routing node. Then we have lightweight wallet. This contains a wallet and a network node on the Bitcoin P2P protocol without a blockchain. Next is the pool protocol servers. These are gateway routers connecting the Bitcoin P2P network to nodes which are running other protocols such as pool mining or stratum nodes. Then we have mining nodes. Mining nodes contain a mining function without a blockchain, but with a stratum protocol node or other pool mining protocol nodes. Lastly, we have a lightweight Stratum wallet. This contains a wallet and the network node on the Stratum protocol without a blockchain. Joining Bitcoin network. Now let's understand the process of joining a Bitcoin network. There are certain special nodes in the Bitcoin network called seed nodes, which have the list of addresses. Joining nodes ask for the list of addresses from the seed nodes. The uptime of seed nodes is generally high, and they have had several connections to different other nodes. The purpose of these nodes is to be used by nodes that are joining the network for the first time to get a list of other nodes which they can connect to. The DNS seeders are responsible for providing a list of seed nodes. As a contingency, Bitcoin Core also has some hard-coded fallback seed nodes which are used in situations where the DNS seeders are not available. In response to the node's request to join the network, the seed node sends them the address list. Joining Bitcoin network. The joining node then picks up an address from the list and joins the network. The newly joined nodes then gets the most recent blockchain from its peers. Do note that the nodes here do not directly connect to the seed nodes as a normal node would. Instead, the nodes connect. They request the IP addresses of the other nodes in the network and then disconnect. The nodes then connect to the other nodes that had been given in the message, which was sent as a response. Mining in Bitcoin blockchain. Bitcoin mining process. Bitcoins are created by the process of mining. Following are the steps in the Bitcoin mining process. Autonomous checks of every transaction. This process allows the miners to verify each transaction against a checklist of instructions. Independent aggregation of transactions into new blocks. This process allows miners to put the transactions into a block to start mining. This block is called a candidate block. Independent confirmation of new blocks by each nodes. Once the miner announces a new block to the network, every miner confirms the block to check if it's valid. Independent selection by every node of the chain with most cumulative computation. This allows blocks to be assembled as part of the blockchain. Autonomous check of transaction. Bitcoin mining process. Now we will take a look at each of these steps in further detail. Autonomous check of every transaction. Each Bitcoin node that gets the transaction will initially verify the transaction. Every node in the blockchain network confirms each transaction against a long list of criteria specific to the concerned blockchain. Then, the transaction is verified by each node and is considered valid with the current blockchain only if the script of the transaction matches the already given set of whitelist scripts, avoiding any infinite loops and unusual scripts, and it does not conflict with other transactions that you have relayed after updating the blockchain. Bitcoin mining process. Each node verifies every transaction against a long checklist of criteria. Independent aggregation of transactions. Bitcoin mining process. Independent aggregation of transactions into new blocks. Miner nodes aggregate the transactions in a candidate block. Each node fabricates a pool of valid, however unconfirmed transactions known as the transaction pool, memory pool, or mempool. Unlike the other nodes in the network, miner node will then aggregate all these transactions to create a block which is called a candidate block. Bitcoin mining process. Let's take an example to understand the step-by-step process of creating a candidate block. Let's assume that a miner node is listening for a transaction, trying to mine a new block, and also listening for blocks discovered by other nodes. As a miner node is mining, it receives a block. Let's call it block number 273816 through the Bitcoin network. The arrival of this block signifies the end of competition of the block. While the miner node was searching for a solution for this block, it was also collecting transactions in preparation for the next block. By now, it has collected a few 100 transactions in the memory pool. Upon receiving block number 273816 and validating it, miner node will also check all the transactions in the memory pool and remove any that were included in this block. Whatever transactions remain in the memory pool remain unconfirmed and awaiting to be recorded in a new block. Miner node immediately constructs a candidate for block number 273817. This block is defined as the candidate block as it is not yet a validated block. It's not valid because it does not contain a valid proof of work. The block will be regarded valid only if the miner is successful in finding a solution to the proof of work algorithm. Mining puzzle. Bitcoin mining process. Now the miner nodes start solving the mining puzzle. Mining nodes construct the block header using the following fields: version, Merkle root, previous block hash, difficulty target, and nonce. The primary aim is to compute a value for the nonce that gives a result in the block header hash, which is lower than the difficulty target. Bitcoin mining process. The miner who solves the puzzle the fastest generates the block. Immediately, the mining node transmits the block to all its peers. They receive, validate, and then propagate the new block. Bitcoin mining process. Since miners use their valuable resources to validate the block, they are giving a monetary reward. A successful miner is rewarded with newly created bitcoins. The block reward is halved every 210,000 blocks, or approximately every 4 years. Bitcoin mining process. Independent confirmation of new block by each node. In Bitcoin's consensus mechanism, each new block is validated independently by every node on the network, which ensures that only valid blocks are propagated on the network. Nodes validate the block by checking it against a long list of criteria that must be met. Bitcoin mining process. Independent selection by every node of the longest chain. Assembling and selecting chains on the block. In the network shown on the screen, once the node in orange color validates the block, it assembles the chain by connecting the block in the existing blockchain. This step adds the blocks to the blockchain, thus confirming all transactions which were a part of the block. As a reward, the miner who mined this block received newly minted bitcoins. Bitcoin mining process. Bitcoins are thus assembled in the longest chain. By choosing the greatest difficulty chain, all nodes in the long run accomplish a wide consensus. Brief errors between chains are settled in the long run as more proof of work is included, broadening one of the conceivable chains. Mining nodes vote with their mining power by picking which chain to extend by mining the next block. The longest chain used to assemble Bitcoins is called the main chain. The other chains created in the process of attaching new blocks to the blockchain are called secondary chain. Lastly, the block added to a secondary chain which never made it to the main chain is called as an orphan block. Key takeaways. This brings us to the end of this second module. By now, you should be able to explain the term Bitcoin and ways to procure them, set up a Bitcoin wallet, identify where to spend Bitcoin, describe the transaction structure of Bitcoin blockchain, interpret the role of Bitcoin scripts in transactions, explain the network and nodes in Bitcoin, and identify the steps involved in Bitcoin mining. Ethereum. Objectives. By the end of this lesson, you will be able to describe Ethereum and its concepts, install Geth and Ganache on your computer, use MetaMask and connect it with Ganache, and install and use Mist Wallet. Ethereum and its concepts. Ethereum. Simply put, while Bitcoin is defined as digital money, Ethereum is a decentralized platform that runs the smart contracts exactly the way they are programmed without any downtime, fraud, and third party interference, and also has its own cryptocurrency called Ether. Ethereum aims to enable innovations in three key areas: currency assurance through Ether, which serves as an innate currency for the Ethereum blockchain, decentralized autonomous organization, smart contracts. Features of Ethereum. The first feature of Ethereum is that it is secure because it is almost impossible to tamper with the transactions in the block or to add any fraudulent blocks in the network. The second feature of Ethereum is its community following. Ethereum has attracted a lot of attention from people all over the world. The third feature of Ethereum is its corporate-friendly structure. The platform is being leveraged by a number of corporates to test and build various applications. The fourth feature that we will take a look at is the possibility of creating new assets on Ethereum blockchain that can be used as currency, a representation of an asset, a virtual share, a proof of membership, or anything at all. The next feature is the ability of Ethereum to process the transactions fast. While Bitcoin requires a block time of 10 minutes, in Ethereum, it's only a few seconds. The last feature that we will discuss is the fact that Ethereum is uncensored. Ethereum's open source network allows complete transparency to view every transaction. All right, that's all about the features of Ethereum. Let me tell you about an important concept in Ethereum called gas. Gas in Ethereum. Gas is the fundamental block of Ethereum ecosystem that is paid for every operation performed on the Ethereum blockchain. It is the crypto fuel for Ethereum. It can be considered a transaction fee, which has to be paid when one party sends ethers to another party. Even when a person deploys a smart contract on the Ethereum blockchain, a transaction fee needs to be paid for that as well. This payment has to be made regardless of whether the transaction succeeds or fails. Gas price is expressed in Ether, and the miner decides whether to refuse the transaction process or not based on the expected gas price. One can see their transaction fee in ETH or USD, when searching for the transaction on etherscan.io. When somebody refers to gas, they are either talking about gas price or gas limit. The total cost of a transaction is the product of gas limit and gas price. The gas limit is defined as a limit since it's the maximum amount of units of gas one is willing to spend on a single transaction. This avoids situations where there is an error somewhere in the contract and you end up spending a very high amount of gas. However, the units of gas required for a transaction are defined by the amount of code executed on the blockchain. Lowering the gas limit below the amount required will not help much. If enough gas to cover the computational resources of the network is not supplied with the transaction will fail due to an out of gas error. So, gas is a commodity which is essentially a cost of using the system. Like Bitcoins, Ethereum also has its currency, which is called Ether. Ether. It is an incentive that the client of the platform pays to execute requested operations. It ensures that the developers write error-free codes because unnecessary codes will increase the cost. Ethereum is a blockchain-based platform, and Ether is the cryptocurrency that fuels the platform. It is commonly denoted as ETH. Let's have a look at the differences between Bitcoin and Ether. Bitcoin versus Ether. The first difference is in the hashtag algorithm used by these cryptocurrencies. While Bitcoin uses SHA-256 to encrypt blocks of blockchain, Ethereum uses Ethash to encrypt blocks. Technically, both are one-way cryptographic hash functions. The second difference is in the use of Bitcoin and Ether. As we have discussed earlier, Bitcoin is only used for financial transactions like purchase and sale of goods and services. However, Ethereum, being a Turing-complete platform, also supports smart contracts and decentralized applications. The third difference is in the price of the two cryptocurrencies. Currently, the price of BTC is approximately 3,500 US dollars, while that of ETH is approximately 100 US dollars. The market cap of BTC is almost 6 times greater than that of BTC, even though ETH has a higher circulating supply. The fourth difference is in the vision behind creation of these two cryptocurrencies. BTC is a currency created to compete against the gold and flat currencies by acting as an alternative. However, ETH is created as a token to facilitate smart contract deployment and operations. Lastly, the transaction speed of BTC is much slower than ETH. While BTC's transaction speed is measured in minutes, ETH is just a few seconds. Like Bitcoins, Ethers are also stored in cryptocurrency wallets. Let's understand what are wallets in Ethereum. Ethereum Virtual Machine, Ethereum Wallets. A wallet is the place to securely store ethers and other cryptocurrencies. Basically, a wallet stores the means of accessing your currency using the private key. Now that I have told you about the Ethereum and its currency, it will only be fair that I explain EVM now. EVM. Ethereum Virtual Machine, abbreviated as EVM, is an engine which executes translation code. Smart contracts are compiled into bytecode, which an EVM can read and execute. The Ethereum Virtual Machine can be regarded as a quasi-Turing complete machine. It possesses its own programming language, known as the EVM bytecode. Once the code is written in higher-level programming languages, the code can be compiled to an EVM bytecode. The Ethereum Virtual Machine uses a set of instructions called opcodes to execute specific tasks. Thus, if a user triggers a transaction of 5 ETH using his desktop wallet, the wallet sends the message to the EVM, which connects with the wallet address on the Ethereum network to process the transaction and send it to the receiver. Smart contracts are written in Ethereum-specific programming languages. Let's learn more about these languages. Ethereum languages. Every contract written for Ethereum is compiled into the EVM bytecode and deployed to Ethereum blockchain for execution. Ethereum uses the following languages. The first language is Solidity. Solidity is an object-oriented, high-level language used for implementation of smart contracts on the Ethereum blockchain. Solidity was influenced by Python, C++, and JavaScript. It is designed to target the EVM. The second language is a low-level Lisp-like language. Abbreviated as LLL, it is one of the original Ethereum smart contract programming languages and is similar to assembly. It is meant to be a very simple and minimalistic language, essentially serving as a tiny wrapper over coding in EVM directly. The third language is Viper, which is a contract-oriented programming language influenced by Python. The fourth language is Serpent, which is an assembly language that compiles to EVM code that is extended with various high-level features. The next language is Muton. Muton is similar to C-like language and supports a dynamic, full higher-level language. It compiles to native Ethereum assembler. However, Muton is now deprecated. The last language is Julia. It is an intermediate language that can compile to various different backends like EVM 1.0, EVM 1.5, and EWASM. Let me now tell you about the accounts handled by Ethereum. Types of Ethereum accounts. Externally owned accounts. EOA is an account controlled by a private key that has the ability to send ethers and messages from it. Following are some of the properties of an externally owned account. Firstly, it has an ether balance. Secondly, it can send transactions. Thirdly, it is controlled by private keys. And fourthly, it has no associated code. Smart contract. Smart contract is a code running on top of the blockchain, containing a set of rules for the nodes to agree upon so that they can interact with each other. As an account, it has the following properties. Firstly, it has an ether balance. Secondly, it has an associated code. Thirdly, a code execution is triggered by transactions or messages received from other contracts. And fourthly, when executed, it performs operations of arbitrary complexity. Some of the advantages of smart contracts are as follows. First, smart contract is the simplest way of implementing decentralization. Second, it provides a high degree of security. Third, it eliminates the need for a third party. Fourth, it provides automatic agreement enforcement. Fifth, it turns legal obligations into an automated processes. And lastly, it lowers the transaction cost. Characteristics of smart contracts. Smart contracts are self-verifying and self-executing. They operate autonomously to execute the terms of the contract and verify the transactions without the need of a third-party intervention. The elimination of third parties reduces the cost of operations and further makes the contracts tamper-resistant. Process of smart contracts. In this slide, we will understand how the smart contract works. First, an optional contract between the parties is written as a code into the blockchain. The individuals involved are anonymous, but the contact is made through a public ledger. Then, a trigger event like an expiration date or a strike price is hit, and the contract executes itself according to the coded terms. Next, regulators can use the blockchain to understand the activities in the market while maintaining the privacy of an individual's position. Let me show you the implementation of smart contract in a simple use case. Smart contract example. Here we have an example showing the purchase and sale of a house. Thus, once a buyer is matched with a seller, all assets are sent into the contract. The contract then distributes the assets based on certain predetermined conditions agreed between both parties and coded into the smart contract. Thus, the settlement is automated and the ownership becomes undisputed due to the transparency of blockchain. EOA versus smart contract. In this slide, we will understand the difference between an EOA and a smart contract based on four critical properties. Nonce. In an externally owned account, nonce represents the number of transactions sent from the account's address. However, in a contract account, the nonce is the number of contracts created by the account. The next property is balance. This number shows the amount of way owned by the address, whether the EOA or the contract account. Each ether is divided into 1E plus 18 WEI. The next property is code hash. It is the hash of the Ethereum virtual machine code of an account. This is the code that gets executed if this address receives a message call. It is immutable and thus it cannot be changed once the construction is done. For externally owned accounts, the code hash field is the hash of the empty string. For contract accounts, this is the code that gets hashed and is stored as the code hash. The last property is storage root. It is a 256-bit hash of the root node of a Merkle tree that encodes the storage contents of the account encoded into the tree as a mapping from the keycache 256-bit hash of the 256-bit integer keys to the RLP encoded 256-bit integer values. This tree encodes the hash of the storage contents of this account and is empty by default. That was all about the Ethereum concepts and accounts. Let's understand the process of mining now. Ethereum mining. Ethereum mining. Ethereum makes use of proof of work mechanism to ensure security. The algorithm used in Ethereum is called Ethash. Each time an Ethereum transaction is made, a miner is responsible for ensuring the authenticity of information and updating the blockchain with the transaction. Let's consider an example where Bob wants to send 1 ETH to Alice. Now we will take a look at the step-by-step process that is followed in order to confirm this transaction through mining. First, Bob attempts to send Alice 1 ETH. Once Bob's transaction is initiated, it is combined with other transactions that have occurred in the last block. The miners will then validate the block with a new set of instructions. Once validated, the miner creates a new block and is rewarded for it. Thus, Alice receives 1 ETH after the transaction is validated. Ethereum mining. The term transaction is used in Ethereum to refer to the signed data package that contains a message to be sent from an EOA to another account on the blockchain. Ethereum blocks contain two things: a transaction list and a recent state of the ledger that comprises these transactions. In the example shown on the screen, we can see a transaction where one wallet sends 20 ETH to another wallet. The diagram shows the previous state and the next state for the transaction. State storage. The states are assembled into a state tree that is linked to the account and the block. The Ethereum includes state roots that store the root hash of the hash tree, which represents the system state when the block was created. Now we will take a look at the step-by-step process to see how Ethereum stores transactions. First, a hash is generated for each transaction. Then pairs are selected and a hash is generated for each pair. This way, the last remaining hash becomes the root. The block header as seen in the image on the screen contains the previous block hash and 3 Merkle trees. These trees are to maintain the state, to maintain the transactions, and to maintain the receipts. Also, each block always refers to its previous block's hash. Ethereum ecosystem. Types of Ethereum tools. The Ethereum ecosystem consists of 8 major tools. They are Geth, Ganache, Parity, MetaMask, Mist Wallet, Swarm, IPFS, Whisper. Now, let's move forward and take a look at each of these in detail. Geth. Geth is a multi-purpose command line tool that runs an Ethereum node implemented in Go. It is the official Golang implementation of the Ethereum protocol and is commonly used to interact with the Ethereum network. Though there are several ways to download Geth, the fastest one is to get it from the ethereum.org website. Next, we have Ganache CLI. Ganache CLI. Ganache CLI is a customizable and fast emulator for blockchain, which permits making calls to blockchain without the need for running an actual Ethereum node. Following are some of the properties of Ganache. Firstly, transactions are mined instantly. Secondly, no transaction cost. Thirdly, accounts can be recycled, reset, and instantiated with a fixed number of Ether without the need for faucets or mining. Fourthly, gas price and mining speed can be modified. Fifthly, a convenient GUI gives you an overview of your test chain events. Parity. Parity is the fastest, lightest, and most secure Ethereum client that provides the core infrastructure essentials for quick and reliable services. Parity is written in Rust language. It offers better reliability, code clarity, and performance. It is an Ethereum client that is integrated directly into your web browser. Apart from allowing the users to access the functions of basic Ether and token wallet, it also serves as an Ethereum GUI browser. It provides access to a diverse range of Ethereum features, including dApps. MetaMask. MetaMask turns Google Chrome into a browser that allows the users to send and receive transactions and also fetch data from the blockchain. It is a browser-based wallet which can be added as a plugin to your Chrome browser. It permits you to run Ethereum dApps directly from your browser without the need for running a full Ethereum node. MetaMask accounts. Practically, it is unrealistic for everyone in the world to run a node to interact with the Ethereum blockchain. To overcome this, MetaMask hosts a number of nodes so you don't have to. A user simply needs to install MetaMask and can automatically get connected to nodes. Thus, you can use the Ethereum blockchain seamlessly. Let's talk Mist, which is another important tool of the blockchain ecosystem. Mist Wallet. Mist Wallet is the end user interface for Ethereum that is developed for browsing and using dApps. Mist is an official Ethereum wallet. It was developed and distributed by the team which is responsible for the management of Ethereum ecosystem. It is usually used by developers who want to create, deploy, and use smart contracts. It is a full node wallet, which means you'll have to download the entire Ethereum blockchain onto your computer. Some of the applications of Mist Wallet is as follows. First, sending and receiving transactions. Second, storing Ether. Third, creating multi-signature wallets. And fourth, deploying smart contracts. Installation of Geth. Let's have a look at a demo on Geth installation. First, we'll visit the official Geth website for installation. Open a web browser and type geth.ethereum.org. That's the official Geth webpage where you can learn everything about Geth. Read what's written there. Geth is an official Go implementation of the Ethereum protocol. You can explore the page later in your alone time. For now, let's visit the GitHub page. There it is. Scroll down to see the installation process. Following are the executable commands which comes with Geth. Scroll down to read more about Geth. The document explains how to run Geth or a full node on Ethereum network. All right, let's go back to the home page and click Install tab to check the installation steps. As you can see, Geth gives you various downloading options. Now, let's check out the Downloads tab. You can download the latest 64-bit stable release of Geth for the primary platforms. Okay, I'm going to show you the installation process for Ubuntu operating system. Let me just open my Ubuntu virtual machine. This is my Ubuntu setup. I have the terminal open to execute the commands. All right, let's get started. Execute the following command: sudo apt -get install software -properties -common. Insert the password. It will start downloading all the packages and dependencies. Wait some time while the setup lasts. Now execute the following command to add Ethereum repository: sudo add -apt -repository -y ppa :Ethereum/Ethereum. All right, so now that the Ethereum repository has been added, let's get the information about what updated versions of packages are available by running sudo apt -get update. Be patient because this will take time. All right, it is updated and fetched the latest packages. Let's now install Ethereum by executing sudo apt-get install Ethereum. The installation starts. Wait for some time while the Ethereum gets installed. All right, that's how you can install Geth in your system. Let me give you a quick recap of the steps I had followed. 1. Sudo apt-get install software-properties-common. 2. Sudo add-apt-repository-y ppa:/Ethereum/Ethereum. 3. Sudo apt-get update. 4. Sudo apt-get install Ethereum. Let me also show you the steps to download Geth on your Windows machine. Step 1. Go to https://geth.ethereum.org/downloads and click on Geth 1.8.17 for Windows. Step 2. Run the exe file and click on I agree. Step 3. Select both Geth and development tools and click on Next. Step 4. Specify the destination folder for Geth installation and click on Install. Step 5. Check the progress of installation and click on Finish. Step 6. Open the command prompt and type Geth command to check if the installation is done successfully. Installation of Ganache. Let me show you how to install and get started with Ganache. All right, let's get started. First, open the browser and type Truffle Framework and open the first link that appears on Google search. This will redirect you to the truffle.com website. Basically, Ganache is part of Truffle Suite. There are other tools like Drizzle, which comes under Truffle Framework. Let's explore Ganache a bit by clicking on Learn More, which opens the Ganache webpage. You see there, that's how a Ganache tool looks like. Let's check the GitHub page to find out how to download the Ganache. Click Download Windows button if you wish to download Ganache for Windows. I'll click Need Another OS Download as I want to download Ganache on Ubuntu machine. All right, let me open my virtual machine where I'm going to download and install Ganache. I'm going to open Firefox and type Truffle Framework to open the Truffle website. Then I'm going to open Ganache page again. And I'm going to click Download Linux button, and I'm going to select Ganache 1.3.0x86_64 Applemage. And save the file. The files start downloading and you can check the progress. Once the file is downloaded, click on the downloaded image. A dialog box will appear saying could not display the image. This is because it doesn't have executable permission. To give permission, right-click on the file and select Properties. A dialog box appears. Click Permissions and make it executable by clicking the checkbox. Now, double-click on the image file. A dialog box will appear. Click Yes to start installation process. Ganache will get installed on your system. Click Continue and your Ganache is ready to use. The Ganache has preloaded accounts. It has blocks transactions and transaction logs. These preloaded accounts are used in test networks. All right, so that's how you can install Ganache on your Ubuntu system. Let me walk you through the steps now. Open Truffle Framework website. Click Learn More from Ganache. Click Download Ubuntu button. Select Ganache Applemosh. Give permission to the image file. Click Continue. You can download and install Ganache on Windows system by following these steps. Step 1. Go to https://truffleframework.com/Ganache and click on Download Windows. Step 2. Run the exe file and click on Next. Step 3. Specify the destination folder for Geth installation and click on Install. Step 4. Measure the installation progress and click on Finish. Step 5. The Ganache emulator will open. Click on Continue to explore the features of Ganache. Transferring ethers using MetaMask. Let me show you a simple demo of transferring ethers using MetaMask. All right, first and foremost, I'm going to open Google Chrome browser and search for MetaMask. Click on the first link that appears. The web page appears. You can scroll down and explore to find out how it works. You can then click on Get Chrome Extension. It will direct you to the Chrome Web Store. Click Add to Chrome button, then select Add Extension. There, you see, it gets added to the Chrome. Now, I'll just click Continue. Here, I create a new password and click Create button. Click Next, accept the terms of use and the privacy note, and click on Accept. Read the phishing warning and accept it. Now just click here to reveal the secret code and click Next. Please note down the secret code as it will be useful in further steps. Now create an account, say account 1. Log into the account. You'll see the balance is 0.